In the following task, the objective is to be able to move all joints. The movement of these joints doesn't have a specific target or trajectory. It is only a way to check that all the motors are working as desired. Because of this, the movements will be really fast and really aggressive. In following tasks, the trajectories will be smoother. This is the program for the axis control of only one of the joints. This program was implemented mostly in a session with Professor Leopoldo Armesto. The only change is the value of some joints. First, we have the defines. This define is going to be used when we want to see the simulation in the Coppelia sim. And it will be commented when we want to put the program in the real robot. This second define will always be commented, as you will see in the following videos, because this is only used when you're using another microprocessor. In this project, there were two options of microcontroller, and I decided to use the Arduino. But in case you choose the other one, this library would have to be used. But, however, I've left the code for this case in case somebody someday will need this with another microcontroller. So now with the libraries, if you're using the other microprocessor, you will need these defines. But since we are using the Arduino, we will only need the library of the servos. We have defined that we have three joints, which are prismatic, revolute, all of them. This is the vector with the parameters of its servomotor, which has already been explained in previous videos. And here we establish the parameters of all the three motors. For the robot simulation, the offset is always 0 because this is an ideal situation. But the minimum and maximum values of the joints are defined by the joint limits. However, if we are not in the simulation but in the real robot, we may need some compensation. For example, this second joint needs an offset of -10 degrees. And again, we have the joint limits. Here we have defined the values that we want for the joints. As you can see, only one joint changes its value each time. For example, this is the home configuration with all the servos at 90 degrees. Then only the first joint changes to 180, then the second joint changes, and finally the third joint changes. And now again, only the first, only the second, and only the third, but with smaller angles that are smaller than 90. Well, this is the code. We will afterwards go back here. This is the right servo function, which has already been explained, and the detach servo function, which has already been explained in previous videos. So what we're doing now is we're starting the serial monitor, which we will see here, and well, this is for the other microcontroller. For all joints, that means from 0, 1, and 2, which are the numbers of the joints, we are writing in each of them, which are, these three, we are writing the angles defined in each one of these vectors. This vector, 1, 2, 3, this other, and this other, and this other. And afterwards, we are leaving a delay of 2 seconds just to ensure that all joints are arriving to the desired position. We will now put this in the simulation to see how it works. Now we're seeing the simulation of the axis control non-coordinated of only one joint each time. So we now start the simulation, and we will see that the movements are really fast and aggressive, as you can see here. And here downwards we have the serial monitor that we've talked about before, which shows the joint values each time that they change.
Okay, now the program has been put in the robot, and you will see that the movements are really aggressive. You will see that the robot is even shaking a little bit. And now it goes back to the initial position.
In this video, it has been shown how to move each joint individually with fast movements. In following videos, we will see how to move several joints at the same time. And afterwards, we will see how to make the trajectory a lot smoother, because now the robot was shaking and this is not something that we want.